In the previous video, we introduced the idea of the limit and solved some basic limit problems. In today's video, we're going to find the limits at discontinuities. So as a review, the limit is the value a function approaches as the input, which is usually the x value, gets nearer and nearer to some value, the f of x value. In this problem, I have the function x minus 2 divided by x minus 2, and we want to find the limit as x approaches 2 of this function. Well, you might say, oh, we can simplify the function to f of x equals 1 since we're dividing x minus 2 with itself. And I would say, well, you're not entirely correct. Because the difference between f of x equals 1 and this function is that this function over here is undefined at x equals 2. Because when you divide anything by 0, that value becomes undefined. But yes, we can rewrite the function to be f of x equals 1 with the constraint that x cannot equal 2. So now let's try to graph this function. So the function will look something like this with a discontinuity, or most commonly known as a hole, at x equals 2. So back to our problem, we want to find the limit of the function as x approaches 2. Well, remembering from the previous lecture, we know that the limit from the left-hand side and the right-hand side must be equal in order for the limit to exist. So by looking at the graph, we see that as we approach 2 from the left-hand side, our f of x is equal to 1. And as we approach 2 from the right-hand side, our f of x is also equal to 1. Therefore, we can say the limit of the function as x approaches 2 is equal to 1. Notice how even though at x equals 2, the value was undefined, there was still a limit. So what you should take away from this problem is that there can be, not always, but can be a limit at an x value despite its corresponding f of x value being undefined. And now I'll show you a case where we have a discontinuity and where the limit does not exist. So in this problem, we have the system f of x equals x squared plus 1, where x is from -3 to 1, where both values are inclusive, and f of x equals -2x plus 6, where x is from 1 to 3, but 1 is not inclusive. And we want to find the limit of the function as x approaches 0, and find the limit of the function as x approaches 1. Let's solve for our first limit. Well, we see that as we approach x equals 0 from the left-hand side and the right-hand side, our f of x equals 1. So we can say that the limit of f of x as x approaches 0 is equal to 1. Now let's look at our second limit. So we want to find the limit of our function as x approaches 1. So by looking at our graph, as x approaches 1 from the left-hand side, our f of x gets closer and closer to 2. So we can say that the limit of our function as x approaches 1 from the left-hand side, which we denote with a negative sign since we're coming from the negative side of x, is equal to 2. And as x approaches 1 from the right-hand side, the f of x is closer and closer to 4. So we can say that the limit of the function as x approaches 1 from the right-hand side, which we denote with a positive sign since we're coming from the positive side of x, is equal to 4. And since the left-hand side of the limit is not equal to the right-hand side of the limit of the function as x approaches 1 does not exist. And as a reminder, a limit that does not exist is not the same thing as the limit approaching infinity. So in recap, the limit is the value a function approaches as the input, the x value, gets closer to some value, the f of x value. And the limit can, not always, exist at a discontinuity. Or in other words, the point does not have to exist in order for a limit to exist. And as a reminder, if you have a limit that equals positive or negative infinity, it is not the same thing as saying that limit does not exist. Thank you for watching this video and hope to see you next time.